Today, we're tackling a big one.
A huge one. We're cracking open what is, I think, the universal language of finance, of economics, really of any long-term decision.
Right.
Time value of money. Or, TVM.
It's a funny place to start because when you first hear that phrase, it
Hmm.
sounds so abstract. You just think, well, a dollar's a dollar.
Right.
But think about physics for a second. Physicists don't just talk about length, width, and height. There's always that fourth dimension they have to account for.
Time.
Time. And that's the perfect analogy our sources use. In economics, money also has that fourth dimension, and it's the one we forget about the most.
So let's define it at the top. The time value of money is, at its core, the idea that a sum of money in your hand right now is worth more than the exact same sum promised to you in the future.
And that single definition, it underpins everything. And the reason it matters to you, whether you're, say, an engineer planning a decade-long project or you're just picking a savings account, it all comes down to one word: standardization.
Okay, so that standardization problem. Tell me a bit more about that. Why can't I just take, $100 I spent in 2024 and add it to $100 I plan to spend in 2034?
Because they're basically different currencies. You're
Yeah.
talking about two completely different units of value.
So it's like adding apples and oranges.
It's worse. It's like adding 5 inches to 5 centimeters. They're both measures of distance, sure, but the sum is completely meaningless until you convert them to a common scale.
To millimeters or something.
Exactly. You have to move both of those amounts of money to the exact same point in time to compare them. And TVM is the set of tools that lets you do that conversion.
Okay, let's unpack this. That totally reframes the conversation. We're not just, calculating interest rates. We're actually creating a standardized way to measure value across time.
That's it. And standard economic theory gives us 4 main reasons, 4 forces, really, that explain why a dollar today is so different from a dollar tomorrow.
These are the forces you have to be compensated for if you're going to wait for your money.
Precisely.
And the first one is, I think it's the most intuitive one, investment opportunity.
If you have that dollar today, you can put it to work instantly. You can put it in a savings account, buy a stock. It starts earning a return.
You lose that if you wait.
You lose a whole year or 10 years of potential growth. That lost opportunity isn't abstract. It's a real measurable cost. You're giving up what that money could have become.
And what that money can buy brings us to the second force, which everyone is feeling right now: inflation.
Right. This is the one you feel at the grocery store. Inflation just means that, on average, prices are rising. A dollar today buys you more coffee, more gas, more whatever, than that same dollar will buy you a year from now.
Its purchasing power is shrinking.
Constantly. So even if the number on the bill is the same, its actual economic punch, its value, is draining away every single day you have to wait.
Okay, so we have opportunity costs and inflation. The third one seems to get into human psychology and just reality. It's risk.
Or uncertainty.
Mm-hmm.
All future promises are fragile. They might be broken.
Money in your pocket is certain.
It's 100% certain. But money promised to you tomorrow, that comes with all sorts of risks. The company promising it might go bankrupt. The economy could crash. There are a million things that could go wrong. So to get you to take on that risk, you need to be paid a premium.
And the riskier the promise, the bigger the premium you're going to demand.
Absolutely. And that leads right into the last one, which is the most purely psychological force: consumption preference.
This one is just about impatience, isn't it?
It is. We are fundamentally wired for immediate satisfaction.
Right.
We don't like delaying gratification. If you have the choice between getting a new phone today or the same phone in a year.
You're taking it today, every time.
So to convince you to wait, to delay that pleasure, whoever is paying you has to offer a sweetener, an extra incentive to make waiting worth your while.
So, okay. We've got these 4 forces all working at the same time: opportunity, inflation, risk, and just preference. Let's make this real. Imagine you're offered $1,000 today, or $1,000 1 year from now.
Easy choice?
It seems obvious, but let's break down why, using these 4 forces, how do they make that future promise of $1,000 just not good enough?
Well, first, your brain instantly calculates the investment opportunity cost. If you know you can get, say, a 6% return in a safe investment.
And you know that $1,000 today becomes $1,060 next year.
Right. So that future offer of $1,000 is already $60 short, just based on opportunity cost alone.
Then you layer on inflation, maybe it's running at 3%. That laptop that costs $1,000 today is going to cost $1,030 next year. So your future $1,000 can't even buy the thing you wanted.
And then you add the uncertainty. the risk that the payment might not even show up. And finally, that little voice in your head, your consumption preference, is just screaming, I want the laptop now.
So when you put it all together, for you to be indifferent, to feel like those two choices are actually equal, that future payment has to be a lot more than $1,000.
It has to be maybe $1,080. And that extra 80 bucks, that premium you demand for waiting,
That's the interest.
that's the interest. And that required interest as a percentage is what economists call the discount rate. It's the total price of time, all four forces bundled into one number.
So if those forces create the gap in value, how do we actually calculate it? That has to bring us to the engine of TVM, which is the math of interest.
Exactly. Interest is basically the rent you charge someone for using your capital for a period of time.
And there are two fundamental ways to calculate it.
The first one, which is the easiest to understand, is simple interest. Simple interest is, well, it's simple, it's linear. Interest is calculated only on the original amount you invested, the principal. It completely ignores any interest that is already piled up.
So the growth is really predictable, but it's slow. It grows by the exact same dollar amount every single year.
And for that reason, you almost never see it in the real world anymore, except for maybe some very short-term bonds. It's a good teaching tool, but it ignores the single most powerful force in all of finance.
And that would be compound interest.
That's the one.
Okay, and here's where it gets really important for you, the listener. This is the concept that changes everything.
It really does. Because with compound interest, we move from simple addition to exponential multiplication. It's calculated on the principal plus all the interest you've already earned. It's interest on your interest.
I've always heard it explained like a snowball rolling down a hill.
That's the perfect analogy. At the top of the hill, it's tiny and it grows slowly. But as it rolls, the new snow sticks to the entire surface area, the original snowball plus all the accumulated snow.
So it gets bigger faster.
And faster and faster. It accelerates. The growth is exponential. That's why the formula for it has that little exponent on for the number of periods. That exponent is the secret sauce.
And over, say, 30 or 40 years, the difference between simple and compound interest isn't just a few $1,000s.
Oh, it's millions or more. Compound interest is so powerful because it basically weaponizes time itself. It turns time into your greatest asset.
Okay, so we've established time changes value, and compounding is the engine that drives that value forward into the future. But a lot of the time in finance, we don't need to know the future value. We need to know what a future promise is worth today. We need its present value.
And this is the bridge concept. This is the core application of TVM. It's called economic equivalence.
What does that mean?
It's the principle that says two different amounts of money at two different points in time can be considered equal in value, as long as you use the right interest rate to convert one into the other.
So if compounding is like a rocket ship that launches today's money into the future,
Then finding the present value is like a time machine that brings future money back to today.
and that process of bringing it back has a name, right?
It does. It's called discounting. When we compound forward, we multiply. When we discount backward, we divide. We're shrinking that future value down to what it's worth today.
And we're shrinking it to account for those four forces we talked about.
Exactly. You have to strip out the cost of lost opportunity, expected inflation, risk, and your preference for having it now.
Okay, let's use a simple example. Let's say the interest rate, our discount rate, is 10%.
Okay. In that world, $100 today is economically equivalent to $110 1 year from now.
You should be totally indifferent between those two options.
Because if you take the $100 today and invest it at 10%, you'll have $110 next year anyway. The values are the same, just at different points in time.
Now, here's why that is so critical for making decisions. Imagine a big company is choosing between two projects. Project A will pay out $1 million in 10 years. Project B pays out $1.2 million, but in 15 years.
You can't just pick Project B because $1.2 million is a bigger number.
It's apples and oranges again.
It's money from two different time zones. You have to bring them both back to today. You have to find their present value to make a real comparison.
So using a discount rate, let's say 8% to reflect the company's risks, we run the math. We discount them back.
And when you do, you find that the present value of Project A's $1 million in 10 years is worth about $463,000 today.
Okay.
But the present value of Project B's $1.2 million in 15 years, that's only worth about $378,000 today.
Wow. So the project with the bigger future payout is actually the worst investment right now.
By a lot. Economic equivalence, through this process of discounting, gives you a single objective number to make your decision. It translates a confusing timeline into one clear answer. Which one is worth more to us right now?
It solves that standardization problem we started with.
It's the whole point.
Okay, so let's bring this all together. Money isn't static, it's a shapeshifter. We've figured out the four forces that make it change: opportunity, inflation, risk, and preference.
And those forces all get bundled into that single number, the discount rate.
Then we found the engine, compound interest, which makes value grow exponentially into the future, and its opposite, discounting, which brings future value back to the present.
So what's the big picture here? What does this all mean? It means that economic equivalence is the key that unlocks all rational long-term planning. It lets us compare massive, complex projects and make smart choices instead of just being fooled by big numbers far off in the future.
And there is no better or frankly more terrifying example of this compounding power than the legendary story of the purchase of Manhattan Island.
It's a perfect case study. The story goes that in 1626, the island was bought from the Lenape people for goods worth about $24.
And for centuries, that's been held up as the ultimate steal, right? $24 for New York City.
It sounds like a historic robbery. But let's look at it through the TVM lens. Let's just imagine for a second that the Lenape had been able to invest that $24.
Okay.
Let's say they put it in a fund that earned a pretty standard long-term market return of 8% compound interest.
And they just left it there for almost 400 years.
If you run that exponential future value calculation, $24 at 8%, compounded for about 400 years, the result is it's almost beyond comprehension.
What's the number?
The future value of that $24 would be approximately $570 trillion.
570.
Trillion.
Now, that's obviously a theoretical number, but here's why it matters. That sum is vastly greater than the entire market value of all the land and all the real estate in New York City today. So the lesson isn't really about the $24.
Not at all. The $24 was almost irrelevant. The real power was in the time. The principal was tiny, but the compounding interest, leveraged over 4 centuries, generated a truly incomprehensible amount of wealth. It proves that in finance, time isn't just a background detail.
It's a force multiplier.
It is the force multiplier. If you understand the exponent, you understand everything.
So here's a final thought for you to chew on. We just established that the present value of a future benefit gets smaller and smaller the further away it is.
Right. The discounting effect is powerful over time.
So if we apply that principle to big public projects like building a dam to prevent flooding 50 years from now or tackling climate change for the benefit of people a century from now, how does the math of discounting inherently force us to prioritize smaller short-term gains over massive but very distant long-term benefits?
That's the tension, isn't it? The math can sometimes point us away from the truly long-term solutions.
Something to think about. Thank you for joining us for this deep dive. We'll see you next time.